Hi and welcome to this quick tool review. This time around I got a bunch of items I found recently. Most of them are inexpensive items that I got from overseas. For a long time I just didn't bother because the shipping times were 3 and 4 months. It was just absolutely insane, which, you know, with the pandemic going on, I can't blame, you know, customs staff for being short and shipping being short and just everyone having a problem getting things anywhere. So, you know, we're all in the same boat. A lot of these items were not items I specifically needed. They're items I'm trying out. I sort of do that as a interest of my own and a benefit to the community, because if I find items that are inexpensive relative to other items of that type but aren't any good, then you're warned and you don't have to try them. And some people would say, well, anything from overseas, not going to bother risking it. But every once in a while you find a gem. And so I'm willing to keep on going. And it's a relatively small investment of money. I get some pleasure out of it. And you know, hopefully you guys find some items that are worthwhile having too. The first item though is an item that I have to say was given to me, donated by Banggood. I was looking for a variable frequency drive because the motor on my belt sander project, and maybe you followed that, it's a 3 horsepower Harbor Freight motor. I don't think it's really 3 horsepower. I've stalled that thing pretty easily. And my Delta table saw has a 3 horsepower motor, and it takes an act of God to stall that motor. So although there's more surface area with the belt, I don't know that I'm really buying it's a true 3 horse. Plus, if you can put a 3-phase motor on there rather than the single-phase motor that's on there right now, 3-phase motors produce more torque for the same power. They're just more efficient torque-producing motors than the other ones. So I'm looking for a variable frequency drive for it, and Banggood offered for me to evaluate this one. So I took them up on it, because this one is not just a standard variable frequency drive. It also claims to be a vector variable frequency drive, which means it's going to try and maintain torque even at really low RPMs. Ordinarily, those are extremely expensive. The high-end ones have sensors on the motor itself that measure the magnetic field that the windings are generating to make sure that the current and magnetic fields are where they want and what they want. This is a sensorless design, so it's a lot less expensive to make, and they make some estimates based on current and voltage. So they do pulse width modulation to control the voltage and the frequency of the output, but supposedly this one will also have current sensors on every leg of the 3-phase out to measure the current, so they can make an estimate of the magnetic field they're generating on the other end. Now there are some entries in the manual that I've looked at that let you set how the motor, how the variable frequency drive is going to work, and I'll get more into that later. Here is the item itself, and you can see the price is insane. It's a 2.2 kilowatts supposedly. We're going to find out a little more. Variable frequency drive. 1 phase in, 3 phase out. There's 3 models of this one. There's 1 phase in, 3 phase out, 1 phase in, 1 phase out, and 3 phase in, 3 phase out. And 88 bucks for this is a flash deal. I think it normally goes for a little over 100 bucks for a variable frequency drive that's good for a 3 horsepower motor or 2.2 kilowatts. If you bought a Hitachi or one of the big name brands, you're looking at 500 bucks easy. No problem. So we're going to take a look at this guy and see if it'll work for me. I figured, what the heck? I can check it out and possibly win in the deal at the same time. All right, so let's open this guy up. Claims the output current is 12 amps. I don't know if that's 12 amps per leg on 3 legs. I could probably calculate that. Don't think I can do it in my head very easily, but 12 amps. I don't know if that's total output across 3 legs. It would be 4 amps a leg. So anyways, here's something that I don't quite get. They're saying it's 8 kVA, 2.2 kilowatts. 8 kVA, if you take 12 amps, well, if you took 12 amps by 240 by 3, 1 for each leg, that might equal 8 kVA. I don't know. Let's take a look here really good. 12 amps, 240 volts, 3 legs times 8.640. So that's how they're calculating the kVA. So yeah, they're claiming it's 12 amps a leg. Anyways, let's pop this guy open. This thing only weighs 1.1 kilograms, and that's with the box. So this thing is light. So it comes with the manual, and nicely enough, on the page, the Banggood page for the product, if you scroll down, they have a link. The manufacturer has a link to the manual right on the page, which is pretty nice. Right there, click to get manual. And they had all the specs on here. Engineering plastic, I like that. That's kind of a funny joke. So there's a manual. I've already looked through the manual because I downloaded it before I ever got this delivered. And the manual is sparse, but I think it'll work. I like the foam. That's a good way to protect this guy. And it has a built-in pot in the front, like so many, with this removable display, which is very common. I think it's an odd approach, but they all seem to have the same exact one. Maybe there's one manufacturer for it. All the same exact display, so maybe there's one guy making all these. So you can use this for speed, or you can use it for other things because it's assignable in the software. Let's pop open this guy and see what contacts we have. Not a captive screw. That would be helpful if you're working on a job site and you don't have a captive screw. That tiny little screw could get lost. Although presumably, if you were working for a business, they probably wouldn't want to risk this kind of variable frequency drive. Although, you know, it may turn out to be quite all right. So the input and output connections here are different than some of the other, actually every other VFD I've ever seen. And I've had some name brand ones, and I've had some made in Asia ones, or made in China ones specifically. They all had, even though it was single phase in, they had 3 phases in. This one literally has ground, line, and neutral. That's the first time I've ever seen that. And then they have the 3 outputs, W, U, and V, which are the 3 phase out. Now this is interesting because I know something that's pretty obvious to me missing off this, the braking resistor. And I was thinking about this a little bit, and I was thinking perhaps you don't need a braking resistor with a vector drive because maybe it feeds volt rather than dump the current coming out of the motor as it's trying to slow it down by basically shorting the windings out or dump them into a load. Maybe this one in the manual said it'll send a voltage back to the motor. Basically, it's a reverse voltage to slow the motor quicker. So maybe to brake the motor, you don't even need, because you can, these assignable keys up here, these X1 through X6, you can make an emergency stop out of it. And so maybe that emergency stop, they backfeed the motor rather than let the current just dump, or rather as the field breaks down in the motor that's spinning at whatever RPM it's going, and then you want to stop quickly, rather than having that field dump the current into the windings and then into a load, you actually send a voltage in the reverse direction to have that current flow even faster and sink it in the device itself. But we'll have to check that out more later. So I'm going to move on to the next tool. We're going to come back to this guy because, among other things, I want to see if I can open it up and just see how well it's put together inside. You know, I don't have super high expectations in that, you know, I know what I'm paying for here. So this is 1/5 the cost of an equivalent unit made by Hitachi or Panasonic or one of the other big brands out there. So I don't necessarily expect to be this to be top of the line, but if it works, that's often really good for, you know, in the home shop guy. So we're going to come back to this guy and I'll also wire it up and power a motor with it. I don't have a 3-phase motor yet, but I have another motor that I had just sitting around that I'm going to try and power with it and just play around. We'll see how it works. All right, so back to this guy. And again, I'd like to thank Banggood for donating this to the channel to give me a chance to check it out. So I'm kind of interested with that. And I was going to pop this guy apart. Always looks like it's the smaller screwdriver. These are Japanese screwdrivers, Hosan screwdrivers, and they tend to fit the Asian Phillips, which are slightly different configuration but compatible with the US ones. So not machine threads, these are sheet metal screws just drilled into the aluminum heatsink. All right, so we might have hung up on this guy here. Fortunately, it's all connectorized, so let's see. Is that what's holding it up? Because there's also fans here, but I wouldn't think that would be a problem. Maybe they're just catching. All right, well, in case I missed something here. Didn't look like there was any, oh, maybe this. Normally all that kind of stuff would fall inside. Looks like this one does not. It's connectorized as well, so they mounted it to the bottom. Ah, it's the, wow, okay. So this is a bit of a surprise to me here, just checking this out. So let's start with the first surprise. Cheap PC boards are paper phenolic. This is fiberglass, epoxy fiberglass. So it looks like they mounted the power devices straight on the aluminum heatsink. Now these are not discrete components. This is really interesting. I don't know if you can see this, but they're arrays. So the three-phase out, these three-phase out comes from one device that has some pins cut off on it. And the input, which should be just a diode bridge, or if they really want to do it, you can actively use a MOSFET like a diode and have lower forward drop and get better efficiency that way. I don't know what they did. I can't actually tell what they are, and I'd have to desolder them off the board to tell, so I'm not going to dig into that. But that's a nice design. I've never seen arrays before, so that's probably help bring the price down. That's smart. And they've done some high voltage relief here, which is really good to see. So these little slots in the border, so you don't get arc across from high voltage sections to low voltage sections, and potentially put dangerous voltages on the parts of the circuit that you can't afford to have it. And a temperature sensor right here. So here's a thermal sensor. There's no Celastic on these, but the connectors seem okay. And can't tell. Oh yeah, it's got a microcontroller on here that looks like SGS Thompson, ST Thompson, which is a big brand. That's a European brand. Yeah, so is this part over here. I can't tell what that is either. So one thing I was kind of looking for was a bunch of sense resistors, which I think maybe could be these guys right here. I don't know for sure. So in order to be a vector control, they need to be able to measure the current output. So they need current sensing resistors somewhere. And it could be these three guys right there. I'm not entirely sure. I don't see any small wires coming off it. The capacitors are 105C. That's good, rather than 85C. So typically in any power supply, the first thing to fail is heat causing the capacitors to dry up and or explode. And these are all 105C, which is more expensive, except for the two big ones. They are 85C. That's not as good. But the small ones are all 105C, which is nice. And it looks like they're using name brand components, which is a little bit surprising. There's two linear regulators here. There's a 7805 and a 7815. Those take DC in and put a regulated DC voltage out. So this is like up to, I forget the number, like something like 32 volts in, then puts a fixed 5 volts out. This one puts a fixed 15 out. And, you know, something's got to power this microcontroller by SGS Thompson. And Celastic on the big caps and the bigger things. So that's good. There's an MOV on the input. That's for surge protection. That's a nice thing to see. It's all surface mount. And that's most of what I can tell about it, just taking a really cursory look rather than just really digging in. But it doesn't look too bad. I'm surprised at the quality, to be honest with you. Everything about this says they went the extra, plus everything's conformally coated. So humidity and things like that aren't going to cause corrosion on the board and or arcing because there's a Celastic coating over the whole board, which is nice. So they went the extra mile on this, which you don't always see. So that's a good start. So next up, let's hook this guy up and give it a test. Alrighty, I found a 3-phase motor that I had here. This was being thrown at work. It's a brand new 3/4 horsepower 3-phase motor, but it was wired for 460 initially. Probably was for our air conditioning guys. This is not an inverter rated motor, so you wouldn't want to run this long time off the inverter. You need one that's got the high voltage coating on the windings and you know, designed not to have any arc points inside, because inverters tend to generate high frequency spikes on the line, a lot of noise, and so you want to be really careful. This is a 3/4 horsepower motor. I've wired it up here. It came wired for 480, and I just shifted the internal wires around and rewired it for 240, 208, 240, which is what I'm going to use it for. And I'll just button this guy up, and we'll give it a shot. All right, so we got it all wired up, powered it up, and by default, this guy came for 50 hertz because it's for overseas, so can't blame him for that. So all you do is you hit the program button, and you look it up in the table what the option is, and it happens to be program 1, option 1 in this little table here. I don't know if you can read that. It's the reference frequency for this guy, and it was set to 50. And all you do is hit enter, take the up arrows, increase it to 60 in my case because I'm in the States, save it. That's done. The maximum operating frequency was P06, which basically sets how fast this it can make the motor go by going over frequency. That was set to 50 hertz, and so I increased that to the max 400 just to play with it. Again, I got to be careful because this guy is a non-inverter rated motor. So all I have to do to start this guy up is choose my startup frequency here, and you can see you can go all the way to 400. Let's just choose line. And the beauty is I can hold this because it's not going to try and turn it all at once. It's going to ramp it. And you can change how quickly the ramp goes in here, ramp up and ramp down. So that's pretty handy. So there's normal line frequency. And if I want it to reverse, it will automatically ramp down to 0 and go back up in reverse, and vice versa. And if I make a change on the pot, like slow it down, there's the maximum slow. You can see it's just barely moving. Let's see if we can get this to go. There you go. 10 hertz. And you can go all the way up. And I don't know if this motor can handle it. Maybe the bearings can't even handle it. But there's twice normal speed right there. This is a Balder motor. It's running really smoothly. And it doesn't make any changes quickly. Also, because it claims it's vector control, and I do believe there are some current sensing devices on the output legs, this guy, even at low frequencies, will still attempt to put out maximum torque. And I don't have an easy way of testing that, but normally if you go really slowly, you lose torque. In this case, I don't think it is. Not that I could stop a 3/4 horsepower motor with my hand anyways, not without a big wheel or something on it, but it seems like it's working great. The operations are pretty simple, and you have 6 programmable controls here that are preset. Also, you can just change that in the programming function. And let's see, do they have start stop? So I'm guessing 5. What is 5? 5 is wire forward operation, reverse is 6, and 9 wire reversing switch. I don't see. Stop. It's trying to figure out their language here. I'd be kind of curious what the emergency stop is, because emergency stop, it could try and just send a lot of current to the motor in the reverse direction to stop it. That would be in 19. So let's change one of these. So we're going to go to program, and we're going to go all the way. Oh, you can't down and loop around the backside. So you can push and hold, and it goes faster, but it's not terribly fast. And when I had to go to 400, it took a few minutes. So we're looking for 50 here. And that is currently set to 13, which is a speed select, speed selection number 1. Let's make that emergency stop. So we're going to make that a 19. So all you do to activate one of these guys is you go between common and the X1, for example, in this case, and that will activate it. So you can do a push button, a simple closure switch, and that should stop it. So let me wire one up. All right, so if we start this guy, spinning. All we need to do is just basically connect these two together. That's what the switch would do. And it slows down. This one is letting it come to an idle. So this emergency stop is basically pull power from the motor, which is not the quickest stop. Let's look at a regular stop, as a matter of fact. You hear how the motor fights itself and comes to a quick stop? That's because it's applying back voltage to the motor to make it slow down. It's on decelerate right now. And one of the options here, stopping modes, let's see if you can see that, stopping modes right here. You get inertial stop, which is basically like this kill did, emergency stop. And then there's deceleration stop and brake stop. And with the brake stop, you've got brake time, 0 to 2.5 seconds, and brake voltage, 0 to 140 volts. Right now that's set, I believe, to 20 volts, so you can make it stop harder and faster. That's program function 14. So it's currently 20 volts. Let's just crank this guy up a bunch. I don't know what's safe, to be honest with you. Not terribly familiar, so we'll not go for the full 140. This is one of the problems with this thing, is that there's no way to get up in numbers fast. You would like, if it would skip the tenths and go straight to these digits at that speed, it would be okay, but this takes forever. If you want to go to a full 140, you'd be here for, well, those are moving about a second apiece. So 2.5 minutes, roughly 2 minutes, 20 seconds. That's kind of crazy. So we'll shoot for 75 volts here. And we will set this to brake mode, which is 2. And I forgot which program number, the feature that was. That is number 12. So let's go to 12. Oops. And it's currently set to deceleration. We'll set it to brake stop. And we will leave program mode, start this guy up. You can feel the motor shudder as it resists it. That's pretty quick. Let's see how it goes with a slightly higher speed. So now we're at just under twice. And you can feel the motor shudder as it back powers it. And it still might be, I might have multiple functions conflicting with each other because it, there's a ramp down time and it may be conflicting with that. I honestly don't know. The brake time itself is actually function 11? No, 13. See, that's currently half a second. Not quite sure how that works. Unfortunately, the manual is not terribly helpful there. Well, as you can see, this thing is very configurable. All in all, I think it's a pretty well-made device considering the minimal cost it is. It's a very lightweight plastic, so it's not going to take a hit. If something runs into it, it's going to shatter. But where it counts, the PC board and the components look like they're pretty good. The terminal's okay, the wire terminals. It has a lot of programmability. It's got 6 button functions that are all programmable, as we talked about earlier. It has an analog in. This SP1 is the analog in on this guy, and that will allow you to set a potentiometer between common and the +5 or +12 rather, and you can set the speed control externally. So you could basically remote all these buttons externally if you want, and that's a nice feature as well. It also has some velocities you can set, fixed velocities, and you can have these buttons jump to a fixed velocity. That by default, it was set to 3 different velocities. It's got temperature protection. You can lower the temperature protection. Right now it's set for 80, which I'm guessing is 80 Celsius. But you could lower that if you want to, have more margin for equipment safety. And that's about. There's a whole bunch of rising velocity and descent velocities here that you could set. You could also put a password on the thing, and anything else that's particularly interesting. You could have it to turn on and immediately go to forward or reverse, which seems kind of dangerous. But I guess in some systems, when you power the system up, you probably want the motor up. Can do that. Right now, the display setting is for frequency. So you go to program, it's in frequency. You could actually have operating frequency, revolution, current, temperature, and time. Current might be interesting. Let's see, that's setting P62 program. Now we got to get up to 62. Here's another one of these things where it would be nice if this was a little bit faster, or you could somehow speed it up, or go backwards from 0 goes to the largest value, etc. So let's see, it's currently set to 1. Let's go to current. So this is a 3/4 horsepower motor. So let's get out of program mode and run. Looks like 1/2 amp. Of course, I'm not quite sure what current it's displaying per leg or what. We could measure that and find out. You also could display temperature, time, and I don't know what the revolution is, but that's another option. That was interesting. The fan came on this. I guess I didn't notice the fan may have come on before. And one more thing we should discuss before we leave here is safety features. So you remember seeing those large capacitors. And by the way, this is all low voltage up here. This is not particularly dangerous, but don't ever mess with anything electrical if you don't understand it. That can be very dangerous, and you can end up really hurting yourself. The high voltage is down here. It's not particularly high voltage, but certainly high enough voltage to kill you if you mishandle it. This is all low voltage control stuff up here. The capacitors in here. So remember I said the AC comes in at 220 on this single phase, and it gets rectified into DC, and then they have those large caps that filter that and pull all the pulses off that, take those big bumps and smooth them off and make it look like slightly rippled DC. Well, those caps hold a ton of charge, and let me just show you how much they hold. So I'm going to go unplug this. Okay, I just unplugged it. It's still running, right? You want to know how much energy they hold? It's enough to partially start the motor. So be really, really careful that you think this guy's off. Make sure the display is out, and if you have, double check with a meter on the output if necessary, because this thing could kill you. It's got enough energy to turn over this motor, which is the highest current part of its function. So startup current is always more than when idling current. So yeah, be very, very careful. But as far as this thing goes, I'm pretty impressed with the quality. Another couple features I forgot to mention in there. I was going to say is they have the vector settings, and I was trying to find them because I always go right past them. Torque compensation is right here, and you can set the torque compensation values and the voltage. I'd love to find a way to test that easily. I may build some sort of test setup at some point in time, but not right at this moment. In any case, for the money, this is a pretty darn good, it's the equivalent of units that are $500+ more, and they have some other options this one doesn't, and they may be a little bit better built. I mean, they're going to have better plastic, and they may use better fans, so if the fans on this die, maybe that could cause the capacitors to prematurely dry out and this thing fail. That's certainly a possibility, but these guys use pretty decent quality components. They use name brand components on a lot of this. The capacitors, I didn't recognize all those brands. I think there's some Chinese brands in there. They didn't use like top tier ones like TDK and Panasonic. But still, I don't have much bad to say about this unit. All in all, I think I give it a thumbs up. And if you want to find it, I'll leave a link below, and you can go check it out for yourself. And if you need different versions, you should be able to find the other versions from there. So thanks for watching. Hope you find it useful. Hope to see you next time.